Hi, my name is Rochelle Penn, a senior in the Department of Civil and Environmental Engineering, working under the advisement of Professor Rissu for my summer undergraduate research experience. This summer I worked on analyzing the effects that certain soil properties have on the soil strength and dilatancy, which is important when it comes to designing foundations for a site and predicting where failure planes occur. So let's take a step back and look at what can affect the behavior of a soil particle. On my walk over here, I walked upon lots of soil and found this piece of gravel. So typically soils are classified by their size, this piece being a gravel since it's larger. Smaller pieces are sand, you can think of beach sand, and also particles that are smaller than that are considered silts and clays. Each soil sample has varying roundness and sphericity values, meaning it's defined in how circular it is and spherical it is. And this inherently affects the strength of the particles. You can imagine that a more angular sand would be harder to shear since the particles would interlock better than if they were perfect spheres. So say you had like glass marbles all lined up on top of each other and you went to shear it. These would just simply roll over each other, whereas a particle that was very sharp, such as this gravel that I found, would have a very hard time being sheared because they'd be interlocked as if like your knuckles are interlocked and would have a hard time shearing across. So for the research I was involved in, I ran many tests called direct shear testing, which is a test that determines the peak shear strength and dilatancy of the soil sample being tested. These tests take quite a lot of time, since you have to prepare the sample, which can take up to 15 minutes, and then you have to wait for the sample to finish shearing. The data that we collected from that test were used to try and determine the relationship between such properties that I explained, such as roundness and sphericity, on a soil strength and dilatancy. I mentioned dilatancy a few times, and this just refers to the soil particle's ability to change in volume while being sheared. Other research that Professor Rissu does includes image analysis of soil particles. I was briefly introduced to this topic and started writing a protocol of one of the systems developed in our lab and worked on some things in Photoshop as well as ideas to improve that system that was developed. I would encourage anyone considering research to do it. You learn so much more than what is taught inside the classroom, and you really do learn new things every day. You have to learn to be patient and that everything doesn't go as planned, so don't be surprised when there are setbacks. But overall, this program definitely encouraged me to pursue further studies, and I'd definitely like to see what else is out there in the research field.